I'd like to spend some time today working on solving equations before we move on to rewriting the uh, equations into variables. After looking at your assessment from last week, there's still a few things that need clarification. One reminder, your goal is to isolate the variable by using inverse operations initially. You want to move everything away from x. You don't want to, in this first equation, move things toward the x to get it set equal to 0. You want to move things away from the x. So as I'm looking at this, you're thinking inverse operations, and you're thinking, in this case, it's a two-step. You want to do the inverse of subtraction, so you're going to add 1 to both sides. By adding 1 to this left side, anything plus its additive inverse will cancel out, and then you're going to get 7x is equal to 21. This is the part, again, where we have a second inverse operation. We're going to divide both sides by 7. And then we simplify and we get x is equal to 3. Didn't ask you to do a check on the quiz, but I did want you to see that you're trying to move everything away from the variable x in order to isolate it. One other thing we encountered was when there were variables on both sides. When there's variables on both sides, we need to look at a few things. So here's a couple of reminders. You want to simplify both sides first. If they need to, you might have to combine like terms, you might have to distribute, you might have to do both. The second step after that would be to move those variables on one side. And then you'll be either left with a variable expression to inverse operations, or you might have either a no solution or an infinite solution result. So let's start. And again, on the right, I'm writing down the steps. Take the time out to write this out, please, because it's going to help you, especially if you had a little trouble on that last quiz. On this problem, I see variables on the left and the right. I can't simplify the left, there's no like terms, and I can't simplify the right. But because there are variables on both sides, I'm going to subtract 3x on both sides. It will cancel out here, and then I'm going to get 3x plus 1 on the left equals 13. Now this looks like the problem on the previous slide. Subtract 1 on both sides. It will cancel on the left, and you're left with 3x is equal to 12. One more inverse operation to get that variable alone, and you will divide both sides by 3. X will be equal to 4. So again, nothing to simplify, but there were variables on both sides. Now let's add more steps. Again, we're going from two-step to multi-step. In my next problem, I'm noticing that there are variables on both sides, but I can also simplify. So number one was, if you can simplify the left or the right, do that first. We need to distribute to simplify, to remove the parentheses. It gives me 4x plus 4. On the right, I have some like terms. Combine them. 11 minus 1 is 10. Now comes the part where you say there's variables on both sides. Let me subtract 2x to bring it over to the other side. 4x minus 2x will give me 2x plus 4. This canceled out, and we're left with 10. Now let's do those two inverse operations. Let's subtract 4. I'm not putting in a whole lot of negatives or fractions or decimals. I'm just trying to go over some basic problems. Last step, if you thought you should divide, you were right. X is equal to 3. This is a multi-step equation with variables on both sides that has just one solution. And that's the type we're most familiar with. But there's more to solving equations than just one solution. In my next problem, again, I have variables on both sides. I might have no solution or infinite solution besides just having one. So let's take a look at one at a time. In this first problem, we see some like terms on the left. Let's simplify and I'll get 6x plus 3 equals, well, I noticed some like terms again. 5 minus 2 is 3. Now you could stop right here and notice that 6x plus 3 equals 6x plus 3, which is an identity. And technically I could stop and say x is equal to all real numbers, but let's go through the process. The process says you should collect your variables to one side. When you collect your variables to one side, it cancels on both sides and you're left with 3 equals 3. This again is called an identity because it's equal to itself. And then we say that x can be equal to all real numbers. And you need to write that down, not just identity. Or you could say it has infinite solutions. So that's the second type of multi-step that we might see. In my last one, we see again some work that needs to be done before we can solve. We need to distribute 6x minus 6. On the right, I have some combined like terms. 7x minus 1x is 6x plus 1. Now I have variables on both sides. I am going to subtract 6x on both sides. It cancels on the left and cancels on the right. This time I'm left with 6 is equal to 1, which is not true. So this is a case where there is no solution because there is no value for x that can be substituted in that will ever make that true. So now I've taken the time to go over a two-step, a multi-step, and variables on both sides. If you need more work, please reach out because you know that you have help in several places if it's still not clear. We then went into talking about, and you had just 5 problems to do, where you had to rewrite an equation for one of its variables. We're going to do it with formulas, but we're going to put that aside for a moment and focus just on this. This is already in your notes from last week. We then took a look at a few problems, and I'd like to do a few. Rewriting equations with more than one variable. We're going to put it in what we call function form. This again is standard form, so I'm first starting off with standard form, which is ax, a number in front of an x, plus by equals c, a constant. Okay, so that's our form. We want to get that into isolating y, which we call the function form or slope-intercept form. We want to put our x term before the constant as well. So looking at this first problem, I have to move the 2x. Inverse operation says let's subtract it on both sides. It will cancel on this side. I'm left with y. I now put the x term in front of the constant, and I'm done. Some of you were trying to solve. We didn't have to solve anything because we don't have enough information to solve. We're just rewriting. In my second problem, again, my goal is to get y by itself. I have to isolate this. So I'm going to add 3x to both sides. It will cancel on the left, leaving me with y. I put my x term in front of my constant, and there it is in slope-intercept form or function form. Let's try maybe 1 or 2 more. I'm going to first move this 5x by inverse operation. I need to subtract. It cancels. Be careful because now I'm left with a negative y. Negative y is equal to negative 5x minus 10. I don't want to solve for negative y. I want to solve for positive y. Property of opposites says I can multiply everything by a negative 1, and that just changes all my signs, and that's the end of that. I do want to show you maybe one more where it comes out slightly different. If I had something like 9x plus 3y equals 12. Now you did have at least 1 or 2 like this on that homework assignment. Step 1 again, let's move the x term. And most of you got that part right. That leaves me with 3y is equal to negative 9x plus 12. But you cannot stop there because y is not isolated. You need to divide everything by 3. That's going to give you y is equal to, let's divide and get negative 3x. Let's divide 12 by 3 and you get 4. So again, sometimes there's an additional step, and sometimes you're going to get perhaps a fraction. If you had a negative 2x plus 3y equals 9, you would start by adding 2x on both sides, and that would give you 3y is equal to 2x plus 9. But once again, you're not done because you have not isolated the variable. You need to divide everything by 3. Divide by 3 gives me y. Divide by 3 gives me 2/3 x, which is perfectly fine. 9 divided by 3 is 3, and that's all there is to rewriting. Some people find this a little confusing at first, but after we do a number of them, they will be easier. So we'll go over a little bit more in person and bring your questions, and we'll clarify everything at that point. See you in class.